Alright, now we're going to start factoring trinomials that look like this: x squared plus bx plus c. So maybe just recall, we already did what we called common factoring. And if you remember that common factoring is essentially the reverse of the distributive property. So the distributive property would have you do a question like this: 2 times x plus 1, and then in the distributive property you'd distribute the 2 into the bracket, so you get 2x plus 2. So this was distributive property. And then when we had to factor, we'd have to go in reverse. So when you factored, you would take a question like this: 2x, or originally you'd be given something like this, and you'd be asked to go backwards. So you'd say, what's common to both terms? Well, there's a 2 common to both terms, so I take the 2 out. Then inside the bracket, I say, what if I divide this by 2, then I'm left with just the x. And if I divide this by 2, then I'm left with just the 1. So you can think of factoring as the reverse of expanding or distributing. But what about if we're asked to expand something like this? Say x plus 2 times x plus 3. So here we have a binomial times a binomial. So we know how to do this, right? We know that you just distribute the first term into the second bracket, and then distribute the second term into the second bracket. So you just distribute both the x and then the 2. So if I distribute the x, x times x is x squared, x times 3 is 3x, and 2 times x is 2x, and 2 times 3 is 6. And then you just add like terms, so the two middle terms are alike. So we'll have x squared plus 5x plus 6. So now this is the type of expression that we want to factor. We want to be able to take this and go backwards. Okay, so let's say we're asked to factor x squared plus 5x plus 6. Well, we know that it's going to be, well, we actually know the answer in this case, but let's just see how we'd get this answer. So we know that it's going to be 2 binomials multiplied together. The first term here is an x squared. Well, how did we get that x squared? How did we get this term? We got this term from multiplying the x and the x. So we know that the first terms have to multiply to give us this. So the first terms are always going to be x and x, or whatever your variable is. Now the question is, what are the second terms going to be? Or how are we going to determine the second numbers? So first, notice this 5. How did we get this 5? Well, the 5 came from adding the 3x and the 2x. And notice the 3, well, that's this number here. And the 2, that's this number here. So the 5 came from adding these two numbers, which will be these two numbers. So whatever number I have here and here, it needs to add to 5. Well, there's lots of numbers that add to 5, right? 1 and 4 adds to 5, 3 and 2, 5 and 0, 6 and -1. There's lots. But now I'll have to look at the 6. Well, where did the 6 come from? Well, the 6 over here, that came when we multiplied the 3 and the 2. So the number here, the 6, must be the product of these two numbers. So you could write that down. The sum, so the two numbers there, we said this number and this number must add to 5. So the sum must be 5, and the product, just rid of p, must be 6. So you need to think of the two numbers that add to 5 and multiply to 6. And there's only two numbers that actually do that. And in this case, we know the answer. The numbers are plus 2 and plus 3. And then you could check just by doing the distributive property. We really checked already on this example. And that's how you factor these trinomials. Any trinomial of this form, and we'll do some examples right now, will work that way. So let's say we want to factor say x squared plus 7x plus 12. So again, we know it's going to factor to the product of two binomials. And we know that the first term, since we have an x squared here, needs to be x and x, because x times x will give us the x squared. But now, what goes here? Well, from above, we know that the sum has to be the middle term. So the sum must be 7, and the product must be the last term, which is 12. So I have to think of two numbers that add to 7 and multiply to 12. And as a suggestion, usually think of numbers that multiply to your product first, because there's fewer pairs that will multiply to 12. So what multiplies to 12? Well, 6 and 1. Or sorry, 6 and 2. But 6 and 2 doesn't add to 7. Try 4 and 3. And 4 and 3 does add to 7, so that's it. It's 4 and 3. So plus 4 plus 3. And that's it. We factored it. You can check just by expanding and you should get back that. I won't do the check, but you could if you wanted. Could do another one. Let's do y. So it doesn't always have to be x. Plus 3y minus 10. So again, two brackets. And now notice the first term is y squared, so we're going to have a y and a y, because y times y is y squared. But again, the sum must always be the middle term, the middle coefficient, so 3. And the product must always be the last term, minus 10. Here notice that the product is a negative number, so that means the two numbers have to multiply to a negative, which should tell you one has to be positive and one has to be negative. So what multiplies to negative 10? Well, 10 and negative 1, or negative 10 and 1, but neither of those add to 3. So we try 5 and negative 2, or negative 5 and 2. And one of those pairs, this pair, adds to 3. Notice this pair adds to negative 3, which isn't what you want. So it's 5 and negative 2, which means we're going to have plus 5 minus 2. And that's it. So you can expand again to check. Maybe one more example. Let's use another variable, z squared minus 7z plus 6. So again, two brackets, two binomials. First term, it's got to be z, because z times z is z squared. And then our product is 6, and our sum is negative 7. Okay, one thing to notice about the signs here is the product is a positive number, and you might think, okay, it's two positive numbers multiplied to a positive. But notice the sum is negative. So since the sum is negative and the product is positive, that means that we need two negative numbers, because remember, two negative numbers also multiply to a positive, and two negative numbers would also add to a negative number. So we're going to think of two negative numbers that multiply to 6. Well, negative 6 and negative 1, negative 3 and negative 2. That's basically it. Well, negative 6 plus negative 1 is negative 7. So that's our pair. And notice that pair doesn't work. So it's just negative 6 and negative 1. And again, you could check by expanding. Let's do one more example. So again, we're going to factor. I'll go back to x. Um, 32. So bigger number here. So again, your sum is the middle number, so positive 4, and your product is the negative number, so negative 32. So again, we're multiplying to a negative, so we need a positive and a negative number. So what numbers multiply to 32? Well, 16 and 2, and then one would have to be negative, and then you could also try 16 and negative 2, but neither of those will add to 4. So what else? 8 and 4, and then let's say negative 8 and 4. If you add those, you get negative 4, so not 4, but 8 and negative 4, that pair should work. So 8 plus negative 4 is 4, 8 times negative 4 is negative 32, so there's our pair of numbers. So we're going to have, again, the x and the x first. We multiplied x squared, and then the numbers that worked were 8 and negative 4. Okay, so that's how you do it. You don't always have to list all your products like this. You know, if you can do that in your head, that's great. Sometimes it helps to list them all. If this is a number with a lot of products, you might end up with a lot of numbers here. Hopefully you'll get to the point actually where you're not listing them all, but if you need to, go ahead. Other thing I would mention is always just do like either a quick mental check, or if you could want to do the expansion, like expand this binomial, just to make sure you're getting back this, your original. Right? If I multiplied, I'll just do that for you. So x plus 8 times x minus 4. So if I expand this, so x squared plus, be minus 4x, and then 8 times x, and 8 times minus 4, so plus 8x minus 2, plus 4x if I group like terms, minus 32. So I get back what I started with, so that's good. I know I did it right. So it's always, either write it down or do a mental check, just to make sure. And there's really no excuse, to get a wrong answer then, because it's very easy to check.